Good morning and welcome everyone. We are going to go ahead and get started. I'm sure people are going to be joining us as we go, but that's okay. We have a full agenda today, so we want to keep things moving. So welcome to the Seaweed Drying Forum. This forum is being hosted by Alaska Sea Grant, the Alaska Mariculture Alliance, and the Alaska Fisheries Development Foundation to support the engagement and knowledge sharing for meeting the seaweed drying needs for Alaska. My name is Missy Good, and I am the Mariculture Specialist for Alaska Sea Grant based in Kodiak. Back in 2016, the governor of Alaska created the Alaska Mariculture Task Force in recognition of the potential of a small industry made up of hardworking Alaskans to have the potential for sustainable growth and development and to have a much larger impact. The final report of the task force outlines a plan to enable mariculture to bolster the economy of our state, particularly our coastal communities, where there's already a significant amount of seafood infrastructure and experience. In addition, the Alaska Mariculture Alliance and the Alaska Mariculture Research and Training Centers were formed to develop and support a robust and sustainable mariculture industry for the long-term benefit of Alaska's economy, environment, and communities. Collaborations and efforts have continued to grow and now include the development districts across Southern Alaska, which has resulted in the U.S. Economic Development Association Build Back Better Challenge funding. With the Southeast Conference as the lead, $49 million have been brought in to support mariculture priorities of tribal, rural, and underserved communities. We have a long way to go in the growth of this nascent industry, but we have the tenacity and capacity to do it. One of the bottlenecks that we see right now is getting our seaweed to markets. Alaskans have shown that we can cultivate seaweeds. We have a couple of businesses that are getting products to markets already, and now it is time to expand that. It has been identified that we need more primary processing capabilities for a dried seaweed product. And so this is why we are all here today. So what I'm going to do now is just give you a very high overview of the agenda. Next slide. So we are going to start off with hearing from Dan Lesh about the Alaska Mariculture Cluster. We're going to go through drying equipment from several of our presenters, processing and markets. Next slide. And then meeting community needs. And then we'll do a wrap-up and closure run by AFDF and the Alaska Mariculture Alliance with Robin and Doug. And at the end of each of the sessions, we'll have dedicated time for questions from the audience to our speakers. You can ask either by typing questions into the chat box to everybody, or if you would like to remain anonymous, you can write questions in directly to myself. I will then read the questions out loud to our session speakers. All session speakers are welcome to discuss and answer these questions, or you are welcome to raise your hand using the icon emoji down at the bottom that's under reactions. We will be watching our screen looking for folks that have their hands raised, and when we call on you, you'll be able to unmute yourself and ask your question out loud. We are recording this, and so it will be made available to everybody on our Alaska Sea Grant website. Each speaker will have the ability to share their screens. A couple of speakers have already sent me their PowerPoint presentations in which I will be moving those slides along for their presentation. Speakers only have 5 minutes, so we are going to be moving very quickly through these presentations. When the speakers are speaking, I will unmute myself and give you a 1-minute warning. At the end of that 1 minute and your time, I'll also say time's up. You will have the ability to finish your sentence, but because we are on such a close timeline, if you go past that, I'm going to mute you. So please don't take that as being rude, but we need to move through our agenda. When we get to the end of that session, that is when everyone will have time to ask questions. And with that, we are going to move on to our first speaker, and that is Dan. So please go ahead and unmute yourself and share your screen. Immediately following Dan, we'll have Chris Sannito on deck starting our drying equipment session.
Thanks, Missy. I'll dive right in. Just wanted to take a moment to remind us all about this once-in-a-generation investment that's going on through the US EDA, the Alaska Mariculture Cluster. It's a competitive nationwide thing and very exciting that we all won this together. So thanks. And there are 7 components. I'm going to talk mostly about the equipment and technology component and the other aspects that are relevant today. Some of the logos here show the coalition that came together to put the grant together. This coalition is growing all the time, and we are excited to add, new partnerships and new contractors to the team. Things are ramping up over the last few months. It's starting to really be exciting and clear that, our project is fully ramped up. You can keep track of all that activity at alaska-mariculturecluster.org, especially through joining our mailing list. There's also an active RFPs location there. In the equipment and technology component, that's 26 million, including match, 16 million in EDA funds, about 33% of the overall. Some of the items that are relevant, about 9 million in equipment purchases that we can make. So those will go to EDA eligible entities that respond to a call that we'll put out here in the next month or two. So we're targeting the end of August or September for beginning of the opportunity to apply for equipment funding. EDA eligible entities are tribes, native corporations, local and state governments, nonprofit organizations. We will have a emphasis on regional approaches that meet a broad stakeholder groups needs. So we want people to be coordinating and coming up with practical but ambitious projects that meet the industry's needs as we start to grow. And the goal overall with this grant is to grow the industry in an equitable fashion and grow to 100 plus times where we are today over the next 10-20 years. We have a variety of ways that we're trying to make sure this grant grows in an equitable way. It's not just one component of the grant, it's infused throughout every component. And we have a governing body that meets quarterly, and these are the members of the body, and they help us keep track of the overall project. And we will have some different information that feeds in metrics that feed into this process to keep us on track and provide input where we fall short or where we need improvement. So there's a mariculture liaison program that'll be kicking off to help facilitate two-way communication between underserved Alaska Native communities in our project. And there's a grant evaluation team that'll also be helping us track these metrics. My name is Dan Lesh. We also, Juliana Leggett and Robert Venables. We got a big team, Kide Coyle and Haley Terpenny, our team here at Southeast Conference, and look forward to working with you in the process. And thanks for working together and coming up with good projects and for the conversation today.
All right, thank you, Dan. Does anyone have any questions for Dan?
Just really quick, slides when he was presenting, so I don't know if those were meant to be shown or not.
Oh, my screen indicated I was showing slides. We can include it in somewhere. So.
Yeah, and I also put a link in the chat box to the Alaska Mariculture Cluster website, and that will have the information that Dan was talking about on it. And we are happy to share slides with folks that register for this. All right, up next, we have Chris Sannito. Chris, go ahead and share your screen and kick it off. And on deck, we have Casey Emmet.
Okay, thank you, Melissa, and happy Friday, everyone. Let me pull up my screen share here. Okay, let's see here. Okay, everyone see that?
Yep, we can see it.
Okay. All right, so this is just a very brief talk about seaweed drying and gonna just go through a few different pieces of information, and here we go. So seaweed, the varieties of seaweed around the world, range from 75 to 95% moisture. And we want to remove the moisture to increase stability, food safety, and also the value density. And that last part, the value density, is really important because, as you know, Alaska is very remote and it just doesn't make sense to ship water out of Alaska. Not very economical. So when we can increase the value density, that's huge. That changes the whole equation. And so to drive that water off, the big thing we need is energy. And although Alaska is not known for solar energy, around the world, solar energy is probably the biggest way that seaweed is dried around the world. So not to say it couldn't work in Alaska in certain situations, but just have to give it a mention. So other than that, we've got electrical energy, and different parts of Alaska have different electrical setups, where in some places electricity is, rather low versus very high in other places. Then you've got your natural gas propane. There are microwave dryers, which would use electricity, but use microwaves to dry. Infrared dryers. And then there's freeze drying. And also, with all of the seafood processing infrastructure we have to consider the waste heat from some of the processes that is just pouring out the building now. This potentially could be recouped for drying. So, for example, in a water-cooled condenser for refrigeration, you've got continuous hot water waste. So, that could be used. And then as far as equipment goes, we've got batch dryers. Batch dryers are where you load a cabinet or a similar type piece of equipment by batch, and you take it out and you load it again and you take it out. Then there's continuous dryers. And for continuous dryers, we've got inline dryers, which product goes in one way and out the other, kind of on a straight line. Then there's rotary dryers, where big batches go through almost like a cement mixer and get tumbled and dried. And then after these blades and things are dried, milling machines would take over, so we can knock it down to a uniform flake size, or even a powder. And then as far as packaging, this would go into polyethylene nylon bags, sometimes with desiccants perhaps, and also polyline bulk fiber drums might be a way of packaging that. So just wanted to show you a few of the varieties of equipment out there for seaweed drying. Some are just fabulous. This Alvin Blanche system from the UK is just a huge machine. You can see where seaweed would get dumped into the hopper over here. Automatic rakes would kind of thin it out and spread it through a climate controlled cabinet with forced air, and out at the end would come dried seaweed. There's versions made in China as well that seem to be very affordable and in use. And you can see there's a HVAC system coupled with the chamber. And up here is what they call a large salad spinner, but these have been used to dewater seaweed before it gets into the line, and that makes for much more efficient drying if we can either hit it with a spinner or even an air knife before it goes off to remove excess water. There's also heat pump dryers using very efficient energy derived from heat pumps to dry seaweed. And then a more simple unit would be just a cabinet batch dryer like this Harvest Saver here. But there's all sorts of drying. I mean, vegetable industry uses dryers, and it's nothing new. So the technology is there. It's just needs to be adapted. And then some of the tools that we would use in the drying process, So the first thing is a water activity meter, and this would be at the back end. We would want to know the water activity, but at the front end, before it goes in, we might want to know the moisture content. And this over here on the right side is called a moisture balance. And you put in a wet piece of material in there, close the lid, infrared rays come down, and the load cell measures until it stops changing weight. And once that has achieved, that says that all the water has been driven off, and it'll calculate the moisture percent. Takes about less than 5 minutes per sample. And then this over here is a water activity meter, and that's telling you what the water is doing in the matrix. And it's a scale that ranges from 1 to 0. And when it gets down to about 0.85 or below, it's considered shelf stable. However, there could be molds and things that grow around 0.85. So really, if you're going to keep mold and stuff off, you need to be about below 0.7. So,
1 minute.
Okay, good deal. All right. I think I got almost a minute to spare. So I could, any questions or any other info to touch on, but just a lot of neat stuff out there for drying seaweed. At our center, we've got forced air smoke ovens, and those can be used without the smoke, just for drying. So we've got a few convection dryers too at the center, and we're soon to be getting another batch dryer. So anyway, yeah, if you ever have questions, I'm happy to try to chase down leads for you and try to get some more information.
Great, thanks, Chris. We're gonna wait for questions until the end of the session. Casey, Emmet, you're up. Go ahead and share your screen and we'll get you pinned there. And Evie, Witten, you're on deck.
Hi, can you all see my screen?
Yes, we can.
Cool. So, hi, I'm Casey Emmet. I'm CEO of the Crop Project. We are a next generation ingredients company. So we believe in the power of regenerative agriculture to bring about transformational change. And of course, kelp is the most regenerative of crops. We turn this into this. And then we further refine and blend kelp with other ingredients so that large food and skincare companies can use it right away. So I'm sure a lot of this will be covered in, it has been covered previously and will be covered in the next presentation, but why drying? I come from a land-based agriculture background. And when I was first looking at this space, it was really clear that one of the central problems with making a market for kelp is that it's 90% water and starts to degrade really quickly, even when refrigerated. And shipping frozen water is really expensive. So if we're ever going to get kelp into as many consumer products as possible, like we do, universally with corn and soy, it needs to be dried. It's obviously a huge need for the entire industry, but particularly in Alaska. And we're working on a couple of projects in Alaska to help solve that issue. And other companies are working to solve the same issue in places like Maine, where we've been doing a lot of our work the past few years. You'll hear from Mitch from Oceans Balance in a bit, and they have some really cool stuff going on. So for some context on our perspective, the United States grows less than 1/100th of 1% of the world's seaweed. The industry here is really, really small at the moment, but there's huge opportunity if together we scale this properly. So looking abroad, globally, as was mentioned, seaweed is typically farmed. Most of it's dried outside on tarmacs and beaches. And that's not much of an option in a place like Alaska. Where it is mechanically dried, the premium kelps, like in Japan, are typically dried in kilns. It's just relatively small batch, old school. The higher volume kelp, like in China, is either dried outside or used as tech, like spin dryers, which we believe results in lower quality. You can lose a lot of the good stuff along with the moisture, and they're super energy intensive. So a few years ago, when we were looking at getting started in this space, the central issue was and remains, how do we marry volume and quality and make it low energy with the small footprint so we don't negate all the great environmental aspects of seaweed? And it's a tough ask. The first year, 2020, right after the COVID lockdown started, we had to hang it in tobacco barns in Connecticut. Not super scalable, but we learned a lot. And we have now, after doing this for a few years, we've focused around some general rules that I believe are universal and that Chris mentioned. First, you need to reduce the piece size. You need to take that huge wet mass of blades and make them smaller. Next, in some cases, depending on your dryer, it's useful to dewater the kelp. And oftentimes that means press some of the water out before it goes in the dryer. And then you need to actually apply heat and dry it. So we started with a heat pump dehydrator. It's a refurbished reefer container that's been tooled to dry. They were using it for lumber primarily. It's a batch system, which isn't ideal for the long term, but it can do about 5,000 pounds a day. And we've learned a lot. Much more recently, we have developed a multi-step drying process that takes that to the next level and can potentially be implemented in any given kelp growing region, but we haven't implemented it yet. And I frankly can't actually share much about it right now. But yeah, in sum, happy to answer questions. I believe this industry is just getting started. There are a bunch of ways to approach the question of drying and milling. And I know from experience that there are plenty of ways to screw it up. I firmly believe that industry collaboration is key. So happy to talk anytime.
All right, thanks, Casey. And again, keep thinking about your questions. All right, next up we have Evie, and on deck is Mitch Lench.
Okay, I'm sharing my screen.
We don't see your screen yet.
Okay, just 1 second, sorry. Here we go. Can you see it now?
Yes, we can.
Perfect. Thanks, Missy. Yeah, my name is Evie Witten, and I am with Regeneration North and working on several nested projects with colleagues at Saltwater, Inc. And also with colleagues at Aleutic Pride. We are focused primarily on drying seaweed and based out of Kachemak Bay. So our goal is to develop viable processing methods as a proof of concept for other coastal communities. We're really focused on the community scale and small farm, small to medium farm scale of growing. And our objectives include to develop methods that are energy, labor, and cost efficient. We also want to engage with farmers and communities to identify methods that are really best suited for their specific context. That might mean using, hopefully means using existing infrastructure and coastal resources to the degree possible. And finally, we're also really trying to align our methods with markets. So to ensure that we are providing products that are ready to go to market. We have been working on this since early 2022, late 2021. We started to design a small pilot project where we started with a high tunnel and hanging in sorry. I am having trouble with my I apologize. I'm having trouble with my thing here, and I think I've, sorry, I think I've shared the wrong version, but I'm going to go ahead with it anyway. So we started in the spring of 2020 with a pilot in one high tunnel, and then moved on and with lessons learned to a more full season in the spring of 2023 using 2 high tunnels. We are now beginning tests with an infrared dryer and planning several different tests with different methods for the spring of 2024 harvest season. I apologize, this is not the version I meant to share. It has a little bit more data in it than necessary, but essentially the high points here are that our pilot in 2022 was really based on the hypothesis, you know, as Chris and Casey have both mentioned, that air drying is the most energy efficient way to go. And it was also using locally available technology, that is high tunnels, which most of you here in Alaska understand that there are a lot of high tunnels, especially on the Kenai Peninsula, that are available. So we started off with 1 high tunnel. It had a small fan in it, a small home dehumidifier, and we equipped it with some supplemental heat, which we didn't end up using last year. And then we also had temperature and humidity sensors. The upshot or the conclusions were we had a really sunny, beautiful season last year, and it worked really well to dry the kelp in a high tunnel. That said, we recognized that we weren't always going to have perfect weather, and we learned that.
1 minute.
Okay, we learned that the dehumidifier was important. In the 2023 harvest season, we modified our high tunnel to include more air intake and more exhaust fans. We had really challenging weather and really challenging results. We're starting preliminary tests with an infrared dryer developed by Nick Zorick at Alaska Fish Company. These are preliminary results, but we're finding that we're getting some beautiful product. In the 2024 season, we're going to test a number of different methods for stabilizing the kelp prior to drying, because we are recognizing that blast freezing is labor intensive and an expensive way to go. So we're trying to figure out other ways to stabilize the kelp and also increase the efficiency and volume of our drying capacity at the same time.
And your time is up.
Thank you.
Thank you, Evie.
Yep.
All right, next up we have Mitch. Give me 1 second. I do have his slides, so I'll get them up for him.
Okay, I can start. Thank you. Thanks for doing the slides too. Hi, everyone. Mitch Lench from Oceans Balance, CEO of Oceans Balance. We are a vertically integrated seaweed company out of Maine. We focus on ingredients, industrial ingredients, as well as we have a CPG brand. Most of our products, pretty much all of our products, are dried. We do a lot of milling. We've been milling for a number of years, powders, flakes, blends. We weren't looking to purchase a dryer. We preferred if someone else did, and we would have been happy paying tolling fees, but it wasn't happening. So we took the plunge, and we got a continuous dryer that was commissioned in May, which has the capacity to do about 30,000 pounds per day, which would be about 3 times of what is being farmed currently in Maine. And like Casey and Evie, we went through all of these iterations, trials, greenhouses, rockweed dryers. We interviewed a whole host of seaweed drying companies before we settled on what we did. Next slide, please. So the key criteria that we were really looking at, there was a number of things. One, it must be able to handle large volumes, because at least one harvest day, which is about 10,000 pounds or so, just for efficiency purposes. Also, it needed to be highly automated, because labor is, I'm sure it's tough in Alaska like it is in Maine, especially in harvest season when people are out on the water. This dryer requires 1 to 2 people. We could do overnight shifts with one person, and we did Most of the time we had 2 people working on it. Energy efficiency, we wanted to keep operating costs very low, as well as have a small carbon footprint, given what our mission is. So we built in some features that reuse the heat. And most importantly, I would say we had a 0 risk tolerance for it not working well after spending a lot of money. We're not a huge company. This was our biggest expenditure to date. Had a friend who's a chemical engineer in the seaweed business for 30 years, worked in hydrocolloids and around the world. And when I told him what our problem was, our issue, he knew exactly what we needed. He knew the company. We went to a company in South Africa who had a lot of experience with this type of technology. And then we basically customized it for farmed seaweed, and especially saccharina, and a couple of seaweeds that are harder to dry than some others. Also, we needed it to be a turnkey solution. None of us had any drying expertise on our team. So we needed a lot of hand holding going through this whole process. We were also really cost sensitive. We did a lot of research, looked at US and European companies who manufacture drying equipment. And partly, I think, because you're in South Africa, labor costs are less expensive. The rand is pretty inexpensive. I think we got a very, very good price. So next slide, please. So some of the lessons learned through the process is, I would say, start the process early. Yeah, it's like right now is a time when you should probably, if you're thinking about getting a dryer for next harvest in the spring, this is a time you need to kind of be digging in. I also say stay away from off-the-shelf solutions. I just don't think they're probably going to work very well. You're going to end up having to customize things in ways that probably are maybe beyond your knowledge. So we really believe that, like, the customization for volumes, your power source, what space constraints you have, all of those things are really important. There's not just one off-the-shelf dryer that's going to fit everyone. Have the engineers also be involved heavily. They came out before we started the project. We talked through it. When we commissioned a dryer, they sent over, it sounds like a ridiculous number of people, 5 people from South Africa with electricians, other people, to make sure we got it up and running, tweaking it as we went through the process. So we got it up and running at the end of May. The other thing I would say is certain seaweed species are easy to dry and others are really difficult. So don't believe, someone saying, hey, we've dried seaweed. Make sure it's exactly the type they've had experience drying, the type of seaweed you're looking to dry, because drying rockweed and other seaweeds can be a lot easier than like, say, saccharina as an example. Next slide, please. This is just a photo.
1 minute.
Sure. This is a photo of the dehydrator. You see some milling equipment. We have a pre-shredding piece of equipment, which actually the engineers helped us find a used piece of equipment, which was very affordable. That helps from a consistency perspective. Working with this team, this friend Colin, 30 years of experience, and this team in South Africa was great, because even after, like, you're always going to find certain things that not everything's going to work 100% perfectly to start with. Like, we found that cleaning the machine, that we need some tweaks to it to clean it a little easier. So they're coming back and we're going to make those tweaks. So you really want, I think, to find a partner who's going to be with you to make sure it's all working perfectly before you say goodbye. And I'd say we do a lot of milling. We're open to working with, I think, companies in Alaska. If they're looking, we've signed kind of an agreement with the South African company and Colin to help others kind of get set up on this. And it's, I think, at an affordable price, and it's going to be, we're going to the guinea pigs. You can see how our dryer works and make your decision from there.
Great. Thank you, Mitch. All right, we're going to go ahead and switch to Travis Bettinson, and Ólavur Gregersen is on deck.
Okay, so I'm on.
Yep, we can hear you, and it looks like your screen is starting to pop up. Still says starting to screen share.
Very good. Okay. So I hope you see my full screen now.
Now we can see your screen.
Thank you. Thank you for the invitation to participate in this. And what I have to say today is, I would say, a bit of repetition of what already has been said, I'm afraid, but perhaps I can also give a bit of insight in our experience with using dryers in the last 5, 6, 7 years where we have produced seaweed, and especially during the last 3, 4 years where we have done it at a certain scale. This year, just a bit about ocean rainforest, we expect to harvest around 500 tons, so around 1 million pounds of seaweed. We are not drying everything, but most of it. But what we are doing, perhaps a bit differently, that has not been talked about so much today, is that we are also fermenting the seaweed, and some of that fermented seaweed we are actually drying afterwards. And that seems to be a product that is sellable and that we can provide customers. So to give you a bit of an overview, I focused on 2 systems that I think are most relevant for seaweed cultivation. It's what we have referred to as batch-based tray dryer. This is a drawing of a similar system that we have in the Faroe Islands. I think the important thing here is that you have a control of temperature and humidity, that you are dependent on how the weather is or the air is outside, but that you can control that. With such a system, you can dry in low temperature or relatively low temperature, and that usually means that you can maintain the bioactive compounds in the seaweed. You can dry whole plants or grounded, and again, that has an impact on which customer segment you are looking at. Based on our experience, you can dry 1 ton for what I said, 100 cubic meters, or I mean, it's a lot. A drying time of 1 ton is roughly somewhere between 24 and 48 hours. It's easy to install. If we look at the pros and cons, it's easy to install. It has a low to medium capex. It has a modest running cost, and you can do high quality drying of whole plants. And this is a known technology. However, it's laborious, high OPEX with energy and labor. You have to do circulation in order to get good quality. When just you're drying it, low throughput volume, and I would say minimum 40 degrees Celsius. I'm sorry about my lack of Fahrenheit, but in order to ensure food safety. The next one is what we already heard about from Mitch. So I'm not going to say so much about that, because I think that will be repetitive. But I can just inform that this is definitely what I see as the future for seaweed drying in large scale, because of the reasons Mitch has already said. And there are now a number of suppliers in addition to the South African supplier. There's Allen Blanche, has always been mentioned, and then there's Murray in the Netherlands, who has provided a system to the seaweed company in Ireland. So I would say that there's at least 3 suppliers or developers that are developing these machines, and then there are also these Chinese options, or the Asian options made in China. And here you have well, depending on which system you choose, they can be low or high in capex. It says low capex. They can definitely also be high in capex, but the OPEX is relatively low, especially compared to the batch dryer. So if I should give some advice when consider what to do in terms of seaweed, yes. So as already said, what type of seaweed are we talking about? Size, morphology, and structure. What's the market you're aiming at? Food or chemical extraction? And also what degree of pre-processing are you able to do? For instance, are you able to ferment before you dry it? And then what's the capex you're looking for? And and then the process that you are able to conduct, whether it requires highly specialized or more commonly approach to the process. And then, so I think it depends very much on the market: food, biorefinery, animal feed, or also if you can use fermented, and that is also determining what system you are going for in terms of batch or conveyor belts. So that was my contribution. I'm happy to answer any questions you might have.
Great, thank you, Ólavur. Ooh. And there goes my timer. Travis Bettinson, you're going to be up next, and then after that, we're going to have our question and answer session. So I see questions coming into the chat box. Keep those coming and be prepared for asking questions here in about 5 minutes.
So again, Blue Dot Kitchen, we are a food CPG company, but we have access to Eastern Washington industrial dehydration, and we've been testing on that and doing some trialing at different industrial dehydrators out in Eastern Washington and throughout the US. We mainly look at dehydration for market in food consumption, and we use 4 factors for consideration in dehydration. Iodine control. Does it concentrate? Is there any way to control it in the process? Throughput, is it continuous or batch? And additives. To use the system, do you need to use significant additives, which then can affect the end markets that your customers will be able to access if you're using heavy amounts of additives for the process? And of course, the kelp product quality at the end. Next slide for anybody who's viewing it in the recording. So we've tested many different systems. I will briefly go through them now, trying to describe them verbally as best as I can. Again, apologies for the visual mix-ups here. The main ones that we've tested on are the apron and belt drying systems that have been mentioned here. So I will not go further into that one to save time. Rotary systems, which also have been mentioned, where a drum will rotate around with products inside of it that are then heated and dried. And spray drying systems as well, where a thin puree of a product, usually relatively clear, is pumped through a chamber up to the top of a barrel. Then from the top, it is sprayed through a sprinkler system to a very small drop particulate size. The chamber is then heated and then dried into a powder, and it is dropped at the bottom. Additionally, we tested on drum dryers, where there is a drum where a puree is spread on top. The drum then is heated, the puree dries as it rotates and is scraped off with a paddle. And we've also tested batch systems such as freeze drying and microwave vacuum drying, where a vacuum is placed on the kelp before microwave radiation is introduced to it, allowing it to heat to a temperature that is maintaining nutrients, but also will dehydrate water because of the vacuum. Using the four metrics that we were kind of trying to adjust for, we came to some conclusions that in this new slide, again, if you're following along, check here, we can make some general assessments on based off of our testing. And the main points that I will factor in here, or the main points that I'll talk about here, are that one, none of the systems had any control of iodine. And I think for food, that is an important factor for a lot of people in the industry who are aware of the concentrations of iodines in kelp. We were mainly testing sugar kelp, just for your own interests and knowledge. And we would recommend that while the dehydration method cannot control kelp iodine contents, that there needs to be pre-treatment surrounding iodine. We do have a process in place for that ourselves. And we have the ability to control iodine in the product, pre-treating it before dehydration. That generally, another conclusion is that generally a continuous system is going to offer higher throughputs in the same time and space as a batch system, but also that continuous systems, for the most part, not always, create a reduced quality product because the heat treatment usually needs to be higher at times. So you get a medium grade to a lower grade product, aside from spray drying, which can produce very high quality products. And the final conclusion is that additive usage is usually needed if the product is pre-treated and pureed, but outside of that, it is not necessarily a major concern. I will stop it there in the shortened time frame. And again, apologize to everybody for no visuals here, as it was a relatively visually oriented presentation. And I'm happy to answer any questions when the timing is right.
All right. Thank you, Travis. Apologies for those issues. If Travis sends me the slides, we will include them in the recording. That way you could come back, you could watch the recording, and you could see the visuals that he had prepared for this. So what we're going to do to start off is I'm going to go through a couple of the questions that were in the chat box. Some of them have been answered by your speakers. Thank you. But I'm going to go ahead and ask them again. That way those are captured in the recording. And then that will allow for our other speakers to go ahead and comment on that as well. So our first question is, do we know what tech companies oversee priorities for scaled drying?
You mind repeating the question?
Do we know what technology companies overseas prioritize for scaled drying? And Tiff, you are welcome to unmute yourself and clarify that question.
Yeah, sorry, it was poorly written initially. It was largely answered through this as people were presenting. So it sounds like the collaboration with South Africa and what Ólavur was talking about is what people are using.
Yeah, and I think just to color that a little bit, I think it feels like everyone has had really similar experience or adjacent experience to us. But the question is, there are a lot of global manufacturers that make great drying equipment for other crops and maybe even different species of seaweed. But having one that actually works and is tested at scale for our case, for mostly sugar kelp, they're relatively rare. So we just try to validate that as much as possible, like, before we actually make a purchase.
All right, I'll go on to the next chat box question. I believe this is for Ólavur. This question is asking for CAPEX versus OPEX, and what do these terms mean? CAPEX versus OPEX.
Yeah, sorry for that. Capital expenditure. So that's the investment cost when you do that, and the OPEX is the cost of operating it.
Thank you. Just give me a second. I'm going through.
When you go through it, I perhaps I could add to the previous question from Tiffany. So I think when we are comparing this, as Mitch also mentioned, it's very important to look at what is the seaweed species you want to dry. The experience that's out there is a lot around Ascophyllum. It's a very different species to dry than Saccharina, for instance. Might also be a bit different than Macrocystis. The agitation in the drying process seems to be a very important part. So a conveyor belt dryer has to have the opportunity to do that, and that also means that you need to get if there's a seaweed species with long blades, that you have to pre-process that into smaller blades, so the agitation actually is possible. So that and then there's the whole after treatment in terms that also has been mentioned in terms of drying and packing. So drying, if you want to do it from scratch in Alaska, I would definitely look at the full, so to say, flow line from the fresh seaweed to the label packaging, because you can have that in one line, in one processing flow. But it's hard to buy a ready solution on Amazon, put it that way.
And I'll also add another pathway into the drying process where the pretreatment that was spoken of by Ólavur was pretreatment through cutting, and then pieces that are agitated through dehydration. There are methods that we've tested where you puree the product ahead of time through a high viscosity mill. And then you can put a sheet out. It does not require agitation, but it's more finicky as an input into the dehydration, meaning that model, sometimes, depending on the machine you're using, does require an additive to bind the extra viscosity coming from the alginates. So it's not ideal if you don't have the right dehydrator, and it speaks to the idea that there is some level of customizing that might be needed. But there is another pathway of pre-pureeing the product through that high viscosity mill and making sure that it doesn't need necessarily the agitation and drying. So adding that into the thought.
All right, the next question we have is, someone is wondering about drying machines that are manufactured in the United States by American companies. And if you know of any, and then also I see Nick Mangini, you've added some comments in there. You're welcome to unmute yourself and provide that information to the rest of the group as well.
I'll take a little stab at this because we did interview some US manufacturers before we settled on the company we went with. One of the challenges in the US is that there's just not a history of a lot of drying of seaweed other than ascophyllum. So ascophyllum in Maine, it's a very common type of seaweed to dry and done in drum dryers. But so like anyone we talked to, if we were going to be really the guinea pigs, like in a big way. And we were nervous about that particular issue because you learn through trial and error. So that's one comment I had.
Yeah, I would say similarly, the batch dryer, exactly what Mitch said. The one thing I would add on top of that is I don't know what, frankly, I don't know what qualifies as made in the USA, but many of the equipment manufacturers that we've tested with are large multinational companies who also manufacture in the US. And we've interviewed and experimented with a lot of those.
I'll add, this is at a different scale, but the infrared dryer we're testing is made in the US, and there are some other infrared dryers also made in the US. It's a continuous machine, but at a smaller scale than some of these others that are being discussed. And very much a trial and error situation.
All right, the next chat is a series of questions from the same person, and maybe what I'll do is I'm just going to read it in its entirety, so it's multiple questions, and then our presenters feel free to answer the questions and aspects that you see as pertinent to you and knowledge that you have in there. So let me read through it. How much production in Alaska for 2024? I will say I'll answer that quickly. In 2022, which is the only year that we have final numbers for, we don't yet for 2023, there's about 800,000 pounds that were harvested. So next question, what is the average wholesale price FOB barge to lower 48? How much surplus carryover is left over from last year? Are markets growing, or are any market barriers still substantial hurdles? Same questions for Maine and the Faroes. So I guess perhaps we can answer how much production was there in the Faroe Islands and in Maine in 2022? And if you have numbers, 2023, and did that crop make it to the market, or is there leftovers?
I can take a step. Sorry, Mitch, you go ahead and then I can follow you.
Oh, I think in Maine, I don't know, have the exact figures, but I think we were like probably about of farmed kelp, probably about 1.2 million pounds, something like that, 1.3. Does that sound right, Casey?
Yeah, that feels right.
And and they're asking about price. They're asking about the wet seaweed price or dried seaweed price?
I'm not for sure. Maybe we could get both from you.
All right. So the wet seaweed prices, there's a pretty wide range, I think, per pound. I think it's anywhere from like about 60 cents to maybe $1.30 or so per pound. Dried is all over the place depending on the company, and it's I guess anywhere from low 20s to mid 30s, I would say. And we do both farmed and wild, so we're kind of like in a little bit of an unusual space, and so we're seeing both prices, and they haven't really converged 100% yet in terms of what that pricing is.
Is all of the kelp that, or seaweeds, I should say, that's being harvested in the both wild and cultivated all going to market, or has there been some that's been stabilized and is still kind of remaining until it makes it to market?
So my understanding, and it's of some other inventory from other companies, there's some pretty large inventory out there.
Yeah, the market's really just getting started. So I feel like we're at a point where we are capable of building up supply really significantly. And a lot of us are working really hard to build out different market channels to support that.
And Ólavur, maybe we can get a similar series of answers from the Faroe Islands. And you're muted.
Sorry. In the Faroe Islands, last year in 23, we were a bit short of 300,000 pounds. This year, however, we have passed that already. We are roughly 1/3 into our harvest. I mean, we are harvesting from May to end of October, early November, and we expect to reach 1 million pound this year. In terms of sales, we were able to sell everything last year. I expect to sell everything this year as well, but it's mainly because we have what we call a functional feed ingredient based on our fermented seaweed. We have a large food producer who uses dried seaweed as an ingredient in some of their product, and then we have an extraction customer. So the market is it's not easy. It's starting up. The interest is definitely there, but it takes a lot to sell seaweed in larger quantities. You really need to be well connected to the buyers. And the other thing is also you have to help the buyers to use it, basically. I mean, because there was one phrase I got from a very large food producer. They said, we are interested to use seaweed as an alternative biomass because it's sustainable, and we are looking for sustainable biomass that can reduce our carbon footprint. But we don't know how to use it in our food. We don't know, we think that the price is too high, so the price has to go down. And if you go down, and if you figure out how to use it, we don't know if you can get it. Are you able to scale it up? Will you be a reliable supplier? And these three questions are kind of also referred to sometimes as the chicken and egg. I don't believe in the chicken and egg. I believe in the chicken that can produce egg. And so therefore I try to start a farm with hens. But that's really the challenge. And that's the challenge for us who are trying to produce seaweed. To get these producers of different products ranging from food, feed, biostimulants, packaging material, and so on, to use that at the same time scale up. And the price, I mean, Mitch has mentioned the prices. I can confirm those, same in Europe. However, what I would like to add, those prices has to go down in order to get into the market and in order to scale up in the way we want. So we have an enormous challenge, both in terms of scaling up production and reducing cost. And drying is definitely a big part of reducing the cost. And the technology that have been mentioned here, I would like that this session was 10 years ago when I started, because then I would have spent more time and effort and money on a conveyor belt dryer back then instead of now, because that is really a key to get into this market. In addition to try to bring functionalities into the seaweed. And as I've said before in Alaska, I really believe fermentation is a part of that. But there was a question also the cost of transport from Alaska to lower 48. We did a trial last year. And that cost is, as the first presenter said, shipping wet weight out of Alaska is not a business. You have to dry it, but I think you could ferment and dry it in Alaska and have a functional product with added value through doing that. but you have to dry it in Alaska, and you have to do it in locations where you have access to sustainable and inexpensive energy. But that's where the fermentation part can come in, because you can ferment large scale without energy and without large investments. And then if you have hops for drying, then you could have a supply chain internally Alaska before you are exporting to the lower 48. So I think this question that you are kind of addressing here, and also with the Build Back Better, is also about trying to figure out how to set up that supply chain.
And I'll also add in a point here that is a little bit tangential, but I think is an important one that is brought up a few times that I want to circle back around to, is the idea that pretreatments are a very energy efficient way to increase to make sure that your drying systems are efficient. What's been mentioned here is shredding the product so that it actually dries quicker because there's more surface area. Dewatering the products usually is an excellent way to remove water from a system prior to dehydration, because almost any dehydration system that uses thermal heat will be less efficient than just mechanically taking it out. So I think that's an important thing to consider in dehydration, is that your focus should be on the whole line and not just what the dehydrator purchases, because it's a process. It's not just one box that you input to a heater. There's thousands of different things you could possibly do to it. And understanding the whole process and the goals of it is really important. And that pretreatments to remove water prior to dehydration could be one of the most efficient ways to actually get it going, and in an energy efficient way.
Great, thank you for that. I'm going to combine a couple of questions right now. So folks are asking, how many kilowatts per pound of kelp dried do these machines take, and how much do they cost? How much capital is needed? And so perhaps if you have these numbers and can share, I know each of you have talked about a couple different pieces of equipment, you could share the kilowattage and the cost.
So I don't have off the top of my head the kilowatts. I know we went through the analysis. I do remember what we kind of came to per pound, the cost of energy costs per drying, and that's obviously going to be different depending on where you're located. But we looked at both electric and gas, natural gas. Where we happen to be, we had natural gas, but could be propane or whatever, diesel, and it was about 43 cents per pound, the cost to dry. So it doesn't tell you the kilowatts, but that's what we factored in as our costs for drying energy wise.
Can I just ask, is that the pound of dried or the pound of wet?
A pound of dried.
I would also add to it that the answer to that question is probably very dependent on the size and scale of the machine and the type of the machine, and that it's usually the best to go to the manufacturer to try to understand the initial specifications of kilowatt hours for whatever size is going to be appropriate for whatever situation you're thinking about.
Yeah, I agree with that.
I can add to this, also to the question, that if you look at the investment costs for this kind of machines, a batch-based dryer will probably be in the area of $100,000, everything included, when you have everything in place at the scale that I was talking about. A conveyor belt dryer is, and I'm not going to hang anybody up here, but my impression is that it's ranging from around $500,000 up to $1 million, depending on scale and how you want to do it. But that's a loose assessment, and there are others here that will know more exact numbers. But I think that's not too far off. I think.
Yeah, I think that's right. And I think, just we're moving on from the batch, but, I think for some growing areas in Alaska, we've looked at this pretty closely. There's not much of a need to do, more than 5,000 or 6,000 wet pounds per day. So something that is a pretty efficient batch system, if it's a little bit cheaper and you can hold on to it for a long time, it might make sense. And there's a pretty good secondary market for those too. But I'm not necessarily recommending making that purchase, but it's an option.
And I would just say what Ólavur said is I would agree that's kind of the right range. And the one thing to factor in and think about too is the ancillary equipment that goes along with the dryer, because you don't just get a dryer, you're generally going to get conveyor belts. You're going to get maybe a shredder or something that breaks it down. Sometimes they include boilers, sometimes they don't. So just thinking about all, and the other thing that's not a small cost that you should factor in is your energy costs of like transforming whatever energy you have to be able to service a big dryer like that. So we looked at electric to begin with. That's where we want to go, but the costs were going to be very high, as well as the lead time with like getting transformers was going to be very high. And that's why we switched over to natural gas. I would have preferred electric overall. So that is very much dependent on your situation, but not a small figure to think about.
I'll add for the infrared dryer that we're currently testing. I don't have figures yet for the cost per pound, but the propane use is relatively high. And so I think we would need to look at conversion to natural gas if we were to make that work.
All right, thank you everyone for those insights. I'm going to go ahead to the next question. Is blanching a key component to the production of seaweed products, or is that considered a separate process for different products? And can this happen after drying?
I would just throw out quickly, it depends on what it's going towards. If it's being used for food, then there needs to be a kill step in your flow somewhere. And so to answer your question, it's totally possible for farmers to macerate on the boat if that's technically capable, but there needs to be a kill step somewhere else, if not there.
And the blanching is, yeah, it's very dependent also on what the end user is using it for. Like if they're using it for, say, pet food, and iodine is a big issue for pets, there may be a need to blanch. You're going to reduce iodine. You're also going to reduce a lot of nutrients. So there's a flip side to blanching, but some people. So we do it's more customized in terms of whether we do it or not, based on the customer. And I don't know if you can do it after. It doesn't sound like you could do it afterwards.
All right, we're going to go ahead to the next question. So I'll read it in its entirety. What about air quality and different toxins that may show up in dried seaweed outside versus inside? I think outside drying versus inside drying. So is there any measure of trace mineral, perhaps wildfires in industry and ability to filter air? Perhaps people will think twice about eating seaweed that is outside versus inside, depending on air quality.
I don't know the air quality as much as there is food safety issues sometimes drying outside, because seagulls and seals or whatever could poop on the there's things that could create issues sometimes drying outside. But I never heard of air quality. That could be an issue now given what's going on in the world, but there's definitely other microbial issues that you can run into drying outside.
All right, I'm gonna go ahead and move on. So someone's asking about kelp to chicken eggs, which are on the market. I don't know what those are, but maybe you guys do. Has any kelp to cows, dairy, or beef made it to the market yet? Blue Barns project? Okay. Yep,
I
I'm
know
not-
that there are plenty of university trials going on. And there are other species that are going to cows commercially, but that's all I know.
I can add there that yes, lots is going on. There's a big interest from the feed producers, from the dairy cattle, or from the dairy the producers of products from dairy cattle to get the carbon footprint down, or to reduce it. But the one thing is, you still don't have the feed mix based on seaweed that gives enough reduction in methane or other benefits that the feed producers are ready to marketize it. The other thing is two challenges. One, they need big scale, and the second, they need very low price, which might be possible because one way of reducing cost is to scale up. But personally, I think that is definitely an exciting area to research on in terms of market and products. But we also have to be aware of that. There's a very stiff requirement on volume and on reduced price in that market.
All right, thank you. Our next question is, are there best management practices developed for the reuse of water and reuse of heat? Or I would ask a general best management practices for drying seaweed.
Reuse of heat for sure. That was one of the big design features that they put into our dehydrator to reduce energy costs, but I don't know about the water question.
I think you can definitely consider, if you have a closed system for dehydration, that if you are in a state, for instance, like California, that if you can dry and you can collect the water in the seaweed and use that water for agriculture purposes, for instance, that is something to look into in larger scale. Because we know that when we dry, and we have done this several times, we collect the water. It's actually drinkable because a lot of the minerals are left in the seaweed. So I think that is the water in itself can be a product when we are talking drying seaweed. If we are on a location where water shortage is an issue from time to time.
All right, thank you. Our next question is a cleaning step required prior to the drying process, or can a farmer macerate at sea and bring a shredded product to the processor?
I think we might have answered that one already.
All right, let's go on to the next one. How long is your processing season? So I guess we'll ask each of you, how long are you processing seaweed throughout the year?
About 3 months, I think, in Maine, from March, April, and to end of May.
So in the Faroes, we are harvesting around 6 months and processing in that period as well. We are planning a new processing plant, and where we also will apply biorefinery, and there we expect to process year round. But there we are also looking at basically 4 production lines: drying, fermentation, biostimulants, and then a certain degree of biorefineries. it's important when we are talking about investing in a dryer of the size we're talking about here, like $1 million or so. That machine has to be in operation as much as possible, ideally 365 days a year, or at least 24/7 during a harvesting season. So it's also, I think, a part of this to look at how can you get enough supply to feed such a machine.
I'm going to move on to another question. We only have 2 minutes left, so I did skip a couple of them, but one that popped out to me is, are these dryers being used for other products besides seaweed in the off seasons?
I answered that a little bit in the chat. We just, as Ólavur said, trying to keep this thing occupied in off season is a big challenge, because 3 months is a lot of CapEx tied up for that period of time. We went out to other seaweed farmers and processors and offered the service to dry for them. But that's in the key season. In the off season, Maine has some ag producers like blueberries and other crops that come in at certain points in the year. So I wouldn't say we haven't figured out how to keep it occupied for the whole year, but for parts of the year. Another good question someone asked was about seafood and shellfish. We've had shellfish people ask us if they could dry shellfish like mussels, and we'd love to do that. We're just not sure that from an allergen perspective, we're going to be able to clean it to a point where we're not going to have issues selling our seaweed, but we haven't kind of bottomed out that particular issue yet.
To Cassidy's question, I would say we're also working with local peony producers and farmers to determine interest in shared equipment over the course of a longer season.
All right. Well, thank you very much for your time and energy and your willingness to present information and answer questions as they came in. It is very much appreciated. And this collective of knowledge is really going to help move the needle forward in Alaska. So I can say thank you from the Alaska perspective. We're going to go ahead and move on to our next session on processing and markets. First up, we have Max Stanley, and on deck is Liz MacDonald and Tom Simmons. So Max, please feel free to share your screen and go ahead and get started, and I'll get your 5 minutes going.
Hi, everybody. I am Max Stanley, one of the owners of Barnacle Foods. We're based in Juneau, and we're both the primary processor and a value-added producer. We've been drying kelp for the last 6-7 years or so. We've gone through a few different iterations, one being cabinet dryers on trays, and now we're doing a rotary hot air dryer, and I'll just show you a picture of that. Let's see. I don't know if that's shared or not.
Not yet.
There we go.
Yep, now it's sharing.
Okay, so that is kind of what we have. Chinese, from a Chinese manufacturer, not the most efficient, but they work for us kind of on a prototype scale, but we're still able to dry about 100,000 pounds of wet a year. So not a huge scale, but gets it kind of for what we need right now. Stop sharing. One of the big things that we see as a challenge for the industry, and Ólavur touched on this a bit, but is price, and just trying to rectify price with the end users and making sure that both the small scale farmers, larger farmers, processors, end users, and consumers all have a price point that works. Going back to, I think, Chris's slide saying that seaweed is 75 to 95% moisture. Talking both from ourselves and talking with other dryers, we're getting a 5 to 10% return, a 90 to 95% loss in the drying process. And so if you extrapolate that out, or you want to convert that in from wet to dry with the price point, you have to multiply what you pay for wet by 10 or 20, and that's going to be just your dry on the material. Then to add to that, you're going to have the capital expenditures, you're going to have your operational costs with labor and electricity or gas, your energy source input. And so that just makes a fairly expensive end product. Being in the $20 to $40 range is kind of what we've seen. And as a food producer, which is a fairly high value product, that's definitely a challenging price point for an ingredient. So it just seems like this is going to be something that we'll have to work on the industry and just see how the numbers can work out and what it means for a smaller scale sell their product at, how much it's going to cost to dry, and then what we can sell it out in the marketplace. Because there is a traditional industry of seaweed and kelp out there, both from Asian markets, from Northern Europe, that are selling dried seaweed at a much lower price point. And so there's how will kind of this newer wave of sugar kelp producers in Alaska and Maine and Europe be able to compete with that. Understanding that as we scale, price will come down, but just looking at kind of where those prices need to be when we're at this stage to know how those kind of investments and scaling is gonna shake out.
1 minute.
So I'll leave it there, and yeah, thanks for everybody for hosting this.
Great, thank you. Thanks, Max. We're going to go ahead and move along. Our next presenters are Liz MacDonald and Tom Simmons. And on deck, we have Nate Schlachter.
I'm going to go ahead and share my screen here. Okay, can you guys see?
Yes,
we
we
go.
can see it.
Great. Thanks for the invitation today. My name is Liz MacDonald, and I'm the Seaweed Supply Director at Atlantic Sea Farms. I'm going to be talking about processing, while my colleague Tom Simmons, who is our ingredient and partner growth channel, will discuss markets. So Atlantic Sea Farms is a woman-run, mission-driven SQF and organic certified seaweed company from Maine. And we partner with local independent farmers whose backgrounds and expertise are deeply rooted in the commercial fishing industry. Over the past 3 years, our expertise in drying seaweed has been laser focused on food safety. And a key standard to elevating the domestic and global markets is knowing what's in your product. So getting it tested is very important. And one of those key testings is micro testing. This standard panel of testing traditionally includes E. coli, Enterobacter, Listeria, molds, Salmonella, Staphylococcus, and yeast. And so with this panel, we're really addressing what typically inspires unwanted microbial growth, especially for long-term product storage. So anywhere from 1 to 2 years. And so after your testing is done, it's really important to be public about it, and you need to share it with your customers. And the additional testing that could be needed is customer specific. So it really helps to learn what's needed early on in the relationship, so that way you can meet those needs and those expectations. And since we're dealing with a really large volume of fresh biomass in a short period of time, it hasn't been cost effective for us to pursue housing and purchasing expensive machinery. And typically, like what has already been addressed, because it would be housed for 9 months out of the year without being used, and it would require seasonal work instead of full-time year-round employment, which is really important to our company. And so that has led us to successfully partnering with co-packers. And the way that that happens is it's after verifying co-packers' credentials and completing in-person facility inspections and the full production process that happens. After it's confirmed that all the required certifications are valid, that they're in place, and that it will meet our customer expectations, that's only then we start working with them, and we select our co-packers essentially based on the following 4 criteria, and in this order too. As you know, everyone in this discussion is really aware of, the throughput is a considerable challenge when finding the appropriate size machinery to ensure scalability for long-term success. And this challenge has essentially strengthened our decision to work with co-packers. And that's really because our volume has changed significantly over the past 3 years while we've been doing this process. So what we needed when we started in 2021, we have already well exceeded come this season we just had in 2023. And if we had in the past, you know, gone and purchased machinery that now would be outdated for what we require, it saved us from unnecessary prohibitive costs. And that has allowed us to maintain the value of the seaweed to the growers, and as well as invest in product development in the market space. And so now talking to markets, I'm going to throw it over to Tom.
Hey everyone, Tom Simmons, ingredient partnerships from Atlantic Sea Farms. I am a relative newbie to the seaweed space. I've been with Atlantic Sea Farms for a couple of years, so I'm feeling incredibly grateful to be listening to all of you and share your expertise. This has been fantastic. I wanted to contribute today by sharing some of the work and some of my areas of focus, kind of how I've gone about having some of those conversations, and then the challenges I've met.
1 minute.
And so areas of focus so far have been really in the consumer packaged goods space, CPG food brands that are looking for innovative, nutrient-dense, delicious, and sustainable ingredients, nutraceuticals and supplements. Everybody's making a greens blend, and kelp powder is a great input for that. The pet space has been using seaweed for over 30 years, and they're looking for more sustainable and domestic supply for that product. Biomaterials, biostimulants, and cosmetics are all great outlets. How I go about having those conversations with the right people who are making decisions, I focus on brands that have really highlighted their ESG goals and their sustainability goals as part of their key business objectives. I've also found that working with folks representing the brand from a strategy side of things or on the marketing side of things that can really see the value in highlighting using kelp seaweed as an ingredient to bolster their position in the market can be really valuable.
And your time is up.
That's great, because Ólavur covered the challenges. I was just going to echo what he said as far as convincing or recognizing how to use it is a big piece, and educating your brands and partners on utilizing the ingredient and being an innovative partner with them. Thanks so much.
Thanks, Liz and Tom. Nate, you are up next, and on deck is Caroline Slootweg.
All right, let me grab my slide deck here real quick and I'll get started. All right, my name is Nate Schlachter. I'm the Vice President of Operations with Blue Evolution. We were founded in 2013, and today we operate 2 site locations, one in Baja, California, and then also in Kodiak, Alaska. And for this morning, I'm going to talk a little bit about our process in drying, which is started in Baja, where we grow sea lettuce or Ólavur. So we have a deep experience in drying, and I think a lot of the learnings and challenges have already been mentioned in the previous panel. We're using a batch dryer that's sourced out of Asia. This is a tray rack, low heat, moving air over the Ólavur to dry. The economics of our site location in Baja have allowed this technology to continue for us, but we recognize that for us to scale, not only in Mexico, but in Alaska as well, that we need to look at additional drying technologies. So to date, we've been operating a 365 operation in Baja. We're able to harvest every 4 days. It's a land-based tank operation. And then we're drying and milling to flake and powder. The first use of the flake and powder for us was in branded CPG products. We had a line of pastas with a low inclusion of the sea lettuce powder, and then a line of popcorn where the seaweed powder was included in the spice blends. We discontinued the CPG line in 2020 to deepen our focus on both food service and ingredient markets. And so today we're continuing to sell both flake and powder into the ingredient market. And in 2020, we really doubled down and invested both time and money, sales brokers, a national strategy in food ingredient sales, not only for the sea lettuce, but also to set up the stage for us to dry the 2 kelps that we grow in Alaska. So in Kodiak, we got our start somewhere between 2016 and 2017. Our first commercial harvest was in 2018. And today we've been blanching and freezing for the food service market. This is a 1 pound pack size. We went to market with that product in 2019, had a hard time through COVID, as everyone did. And it was in 2020 that we realized that we may need to start looking at the ingredient market. I think Casey from the Crop Project mentioned that markets are still emerging and are somewhat infant here in North America relative to looking at seaweed as an ingredient. And so in 2020, we said, let's give it 2 to 3 years. Let's really put our effort behind dehydration. And it's certainly been paying off in the last 12 months. We have the same batch dryer that we utilize in Mexico in Kodiak. We haven't activated it, but we'll be doing so this year with some funds that were received from Build Back Better. And that will allow us to continue to understand what are the differences and similarities in our process in Mexico comparative to Alaska. What are the differences between the seaweeds, and how can we, and then essentially put up sample inventory to go to market. And on the market side, I'll share a little bit. Mitch from Oceans Balance and I were both at a food ingredient trade show in Chicago last week. My sense is that ingredient manufacturers are looking for emerging and novel ingredients that do the things that kelp or seaweeds do. So a lot of our conversations are focused on that nutritional pull-through on different elements that may be intrinsic to the seaweed, and how that may play out in a certain food formulation. Flavor is a big component. This could be a salt reduction, yeast reduction, or just an enhancement through umami. And then certainly the sustainability side of the ingredient that we're producing is a thread that can be pulled through to that formulation and the marketing of the product. So in Kodiak, we'll start here in the fall on a trial basis. And then as we move into the 2024 season, we will blanch and warehouse seaweed that will then draw down and convert to dried product to ship off the island going forward. I'll stop there and we can take more questions after the presentations.
Great, thank you, Nate. Caroline, you're up next.
I'm unmuting yourself. Okay, hi guys, thank you very much. I hope everyone can see my screen. So my name is Caroline Slootweg. I'm the co-founder of Kelp Blue. We grow giant kelp, Macrocystis, and our first farm is in Namibia, so very far away from Alaska. But what's really great is that the growing conditions are the same in Namibia as in Alaska for a giant kelp. So this is what we do. My presentation is going to be more about our approach to it. So I hope you can learn something. And the first thing I would say is focus on more than just the economic benefit. Seaweed is fantastic at doing a lot of things, increasing biodiversity, reducing ocean acidification, carbon sequestration, creating jobs, also all of the products that can be harnessed from seaweed, which I'll get onto a little bit later, just have a spectacular ability to accelerate the change to sustainability. So what's really, I think, important is to not only focus on the fact that it's ocean and it's kelp, but also what you can do to accelerate the change in a lot of other industries that don't necessarily consider the ocean as one of the reasons why they need to invest. So while very much focusing on more than just economic benefit, there is a lot that you can still harness. So what we do at Kelp Blue is we harvest, we process, we also sell What we do is we sell a biostimulants. That's our first product. We have heavily invested in R&D. And from that is how we approach the market. What I would suggest, and this is how we're looking at it, product development is really very interesting. You have to look at where you want to be on the entire scale of what seaweed can be used for. So if the slide that you're looking at right now, you see the center, the core, those are the ingredients. So those are the commodity ingredients that can be harnessed from kelp. But you also have to look at, if you go further down the value chain, what can it be? You have the ingredients. If you want to sell B2B, look at what can be done with those B2B ingredients, but then also look at what the ultimate end products can be. And so what is really important at value creation and really creating an economically scalable model is actually trying to move from a commodity ingredient to further valorization. So what that really means is understanding the product that you're working with, and then doing a lot of market research to understand which markets you find most important that you can go into. So it really is a top-down approach when you have the market tell you what you want, but also a bottom-up approach of what you understand can be harnessed from that seaweed. Our approach is very much what we do is we look at what we can do from the wet kelp. We have multiple streams that we purify and concentrate. We can mix everything. We isolate everything into their components, and you see them here, the ingredients. And then you can further valorize those specific components that you can extract from the seaweed, and you can further valorize them into what the end product is, such as the pharmaceuticals or biopackaging. I mean, it's not only seaweed that goes into biopackaging. There's a lot more. So what I would say is top tips for me really understanding what you can do with the seaweed is get a feel for your seaweed, do your own R&D, even if it's in your garage. Most of the extraction methods for taking out the fucoidins or getting the alginates can be found on the internet, and try it out for yourself. Understand how you can do it for yourself, because what you do then later is maybe you don't want to scale up, but then you can partner with people. We process wet. We have realized now that we indeed do need drying equipment. What we're looking at is spray dryers. We're always looking at air dryers. But in the end, what you do with your seaweed is going to be an economic choice. So start from the market end and work backwards, learn from others, partner with others, and really try and co-develop with a potential buyer. And this has really been key for us. And that is my presentation. So thank you. Did I hit the 5 minutes?
You have 45 seconds left.
Oh goodness. I was so under pressure because everyone's going over. So no, but what I really see about process, because so drying, if you're going to be sending samples to any potential buyers, drying is very important to invest in. This is something that we realized a bit late, but we're working on it right now because it's a lot easier to send dried product around the world, because it's not just something that we ship only to the US or keep within Africa or Europe, but we're shipping it all around the world because we firmly believe in co-development of that final product. So thank you.
Great, thank you. We are going to go ahead and highlight all of our presenters from this session, and we're moving on into the question and answer time. The first question that I saw pop up was to Liz and Tom in regards to having co-packers, and they were asking, is this specifically just for drying? And Liz answered that in the chat box that they use co-packers specifically for drying. But Liz, do you have anything else to add on top of that, or Max?
Sure. I can say that we do have an in-house processing facility that is SQF certified and organic certified, and that's where all of our other retail, ingredient, and wholesale products are created in-house. So drying is just used with co-packers, but not our other products.
And I don't see any more questions in the chat box. Again, feel free to type them into the chat box. If you want to be anonymous, you can ask just me. I do see a series of questions just came in. You could also raise your hand using the reaction emoji down at the bottom, and I can call on you to unmute yourself. So I'm going to go ahead and read this question in its entirety, and then the panel can feel free to answer what they can off of it. We haven't been to Natural Foods Product Expo or Winter Fancy Food Show for a few years, or the show Blue Evolution mentioned. How many bagged seaweed snacks are still out on the market? Cascadian sold Cove, Blue Dot has Citroens. How is this part of the sector performing? More competition or less? What are the promising retail market channels and product forms? The Montauk Seaweed Supply Co. says U.S. consumer adoption needle is barely moving. Besides Greenwave's Eat Kelp, are there any industry-wide attempts to organizing a marketing board? That was several questions, so I can repeat that or feel free to answer as the answers popped into your head.
I can speak to the seaweed snack space, but I'll probably toss it over to Travis to speak towards those bagged seaweed snacks. I think last year something like 3 out of the 4 fastest moving velocities in the retail space in the snack category were seaweed snacks. So that shows no signs of slowing down as far as area of interest. Travis, can you speak to, and sorry to put you on the spot, more of the bagged snack category and what you're observing?
And I don't see Travis in the participant list anymore. He might have signed off.
All right, cool. So I don't have much to share on that one. As far as what Montauk Seaweed Supply Co. mentioned about the adoption needle, I can only go off of what the inquiries I'm getting from the kind of ingredient and recipe development side of things. I'm an eternal optimist, so my view on this might be a little jaded, but I'm feeling really, really positive about the interest and the amount of inquiries that are coming in regarding product innovation and the inclusion of seaweed, whether that's in the form of a first ingredient seaweed product, or if it's about kind of including seaweed in the overall recipe. I would say that the interest is there, but generally speaking, investing in product innovation is definitely slowing down as a result of the market right now. And so that while the interest is there and there's a lot of excitement about it, that innovation slowdown isn't necessarily associated with seaweed, it's associated with product innovation in general. But we are feeling the effects of that in introducing this exciting and new ingredient. That's my piece on that.
Thank you. All right, we're going to go ahead and move on to the next question. I think this was asked in the prior session, but didn't quite get to it. And maybe someone here has some insight. Does anyone have any information on vacuum drying? That's okay. Let's go ahead and move on to the next one. If we are using air drying and thus moving air, we might be considered as filtering air almost through seaweed, if you will, and thus in a world that is struggling more and more with air quality, is there an overlap with air filtration need and air drying? I don't know if anyone here can answer that. That's okay. The little, maybe it would have been better placed in our beginning session. I would encourage any of our session speakers to feel free to type into the chat box from the previous one if you know these answers. So you're welcome to do that. Our next one is, do your companies have experience partnering with growers who are able to receive supplemental income through payment for ecosystem services? If so, has that been successful? If not, has this been an avenue that's been explored?
Maybe I can start on this one. The problem with quantifying the ecosystem services of kelp is that is an incredibly new industry. Just the seaweed industry is very new. And if you compare it to ecosystem services of other nature-based solutions, it's been explored a lot. So if you look at the research and say, for example, what everyone is always talking about is the carbon sequestration potential and the blue bonds that come from cultivating kelp. That is something that a lot of people are trying to research, but the science is not there yet to be able to hand on heart say how much carbon is sequestered by seaweed cultivation. It's something that will still take a very long time to quantify. I would say at least 2 to 3 years. There is already a blue carbon bond that is being issued in Japan for the restoration of kelp forest, and that is a very high amount for 1 ton. That's around $340 if I recall. But even at $340 per ton, it does not make a very significant contribution to the economic model of cultivating kelp. So I would just put a note of caution. It's fantastic that we're doing this, but I think that science still needs to be proven, and we have a long road ahead of us. That's only for carbon. The other ecosystem services, such as job creation, it absolutely exists, but is that something that can be monetized over and above just creating jobs? Not sure in terms of a credit. But we're working on creating a blue bond for sequestration, but our path is still 3 years for creating that carbon sequestration bond.
Can I add that I completely agree with you, Caroline, that more science needs to be done on the sequestration side of things. And it's, seaweed is such a nutrient dense superfood that it's hard to see some of it going into the deep sea when we have a lot of issues with food security globally. And so as a really sustainable food source that can replace other carbon intensive food applications, we see a lot of potential in that space. And then additionally, looking at ecosystem services when you're growing kelp in addition to shellfish. And, we're working on a lot of programs where we're studying the local mitigation of ocean acidification by having kelp farms in the water. And so that's been a really exciting piece of work for us with Bigelow Laboratories for Ocean Sciences, which is based in Maine as well. And it's great because, the people that we work with are primarily focused on shell-bearing organisms throughout the rest of the year. So that's either lobsters or mussels, oysters, scallops, all of our creatures that are going to suffer if we don't work on this pH situation. So, yeah.
Fantastic. Thank you. Once again, I really want to thank our panel for taking the time to meet with us today. This is invaluable for the Alaska industry, and we very much appreciate your insights and willingness to share. With that, we're going to go ahead and take a 10-minute break. We are going to start very promptly at 11 o'clock with meeting community needs. So again, thank you. Go ahead and take a few minutes to stretch your legs, get some coffee and tea.